First, it's important to establish the fundamentals of the synthesis and breakdown of polymers. The reactions that connect monomers are also called dehydration reactions, in which the hydroxyl group of one molecule is added to the hydrogen of an adjacent molecule. This is because dehydration reactions covalently bond two molecules together with the loss of a water molecule. And to illustrate what I mean, we can look at these two monomers here, and if we take this hydroxyl group and this adjacent hydrogen, we can essentially get the loss of a water molecule, so H2O, which will be displaced once these two molecules join together. And this leftover oxygen right here will have two covalent bonds, which will essentially link these two molecules together. And polymers can also be disassembled into their constituent monomers through a hydrolysis reaction. And hydrolysis is the addition of a water molecule to lyse or essentially break a covalent bond. And a disaccharide is a carbohydrate that consists of two individual monosaccharides joined by a specific type of linkage called a o-glycosidic linkage. And the O basically comes from this oxygen that will connect these two monosaccharides together. So as an example, we can look at maltose, which is a disaccharide formed by the linkage of two glucose monomers. Specifically, they are the alpha D-glucose and so on this first carbon, we can see that a hydroxyl group lies below this carbon, and this is why we have the alpha configuration of this glucose. And to get these two sugars to join together, we have to perform a dehydration reaction, which I just previously explained, in which the hydroxyl group of this sugar will bond with the hydrogen of this adjacent sugar, forming a water molecule. And we can draw this. So like I said, there's going to be two covalent bonds and then this oxygen that will link these two sugars together. And remember, when oxygen has two bonds, it also has two lone pairs just like that. And we call this an o-glycosidic bond. The bond between these two glucose monomers rests between the first carbon on the left glucose, so we can label this as the first carbon, and the fourth carbon on the second sugar. And this is why it's called an alpha 1,4 o-glycosidic linkage. Just like that. And so the second most common disaccharide is lactose, which is found in dairy products such as milk. And lactose consists of a beta D-galactose and an alpha D-glucose. And similarly, this linkage that takes place is between the first carbon of the left molecule and the fourth carbon on the right. However, notice that this hydroxyl group on the beta D-galactose is above this first carbon, unlike how the hydroxyl group was below. So what this means is that this is going to be the beta configuration of galactose, and we're going to have the bond take place between this hydrogen and this hydroxyl group. So what it's going to look like remember we have that oxygen left over, but what it's going to look like is something like this, where we have this bond going up, and then we have the oxygen, and then it connects back down. And remember, we have 2 lone pairs on the oxygen. And because this is the beta configuration of galactose, and it takes place between the 1st and 4th carbon of these 2 sugars, it's called a beta 1,4-glycosidic bond. And what we have here is the 3rd most common type of disaccharide, which is called sucrose, and it's formed by the linkage of an alpha D-glucose and a beta D-fructose. And so, unlike the bonds between the 2 sugars and maltose and sucrose, which is a bond between the 1st and 4th carbon of the 2 sugars, so 1st and 4th, this bond occurs between the 1st carbon of this alpha D glucose and this 2nd carbon on the beta D fructose. And so it's going to be the same thing. We're going to take this hydrogen, or this hydroxide group, and we're going to make a water molecule with that adjacent hydrogen. But remember, we have that leftover oxygen, which is going to provide as a linkage between these 2 molecules. And we again have 2 lone pairs. And because, like I said, it's between the 1st and 2nd carbon respectively between these 2 molecules, we're going to form an alpha 1,2-glycosidic bond. And glycosidic bond is synonymous with o-glycosidic linkage. And in humans, we have 3 separate enzymes to break down each of these disaccharides. So for maltose, to break it down, we have an enzyme called maltase, and the substrate is maltose. And for lactose, we have an enzyme called lactase. And for people who are lactose intolerant or have difficulty breaking down lactose, they lack this enzyme right here, lactase. And for sucrose, it's just called sucrase.